Welcome to the place of rest, where our aim is to give you language that helps you displace the growing confusion, chaos, and dis-ease of our times. My name is Jonathan Boyce, and it's my pleasure to bring to you today's episode. Virginia and Dr. Cowden discuss the crucial role of mitochondria, identifying key threats like toxins and electro-pollution, and revealing actionable steps to support and regenerate them. We hope you enjoy today's conversation.
It's wonderful to have you back. We got a lot of feedback, by the way. I'm thankful that you are willing to join me again to discuss a topic that's very near and dear to my heart because I know so little about it. And I think it can solve so many problems for so many people. And that's really to discuss the innermost workings of our innermost being. So I know you have a great presentation for us, and we're going to break this up in two parts. But give us a little bit of introduction as to why you felt compelled to get right on it after going over the central nervous system and talking about neurotransmission and health. I was wondering if you could just lead us into this next discussion.
Yeah, the nervous system is important, but if your nervous system is incapable of producing ATP energy, then it doesn't work. And so it doesn't matter what else you do, you're not going to have, effective functioning nervous system or heart or other vital organs of the body. So I want people to understand at least the basics about the production of ATP energy in our bodies, and that's done predominantly by the mitochondria in our cells. And I'll give more information about the mitochondria during the presentation. But, mitochondria are under-recognized and underappreciated, but without them, we die.
What is the mitochondria exactly?
It's an organelle inside the cell. There's a few hundred in every cell. They're very similar in shape and physiology to bacteria, but we're born with them. We get them from our mother, not from our father, and they hopefully will be replicating during the course of our life so that we always have a few functioning mitochondria in every cell. If a cell gets to the point where it doesn't have any mitochondria, that cell dies.
Okay. What is the best way to approach this immense conversation? Some of these conversations you and I have, I think, are so dense, and I don't want people to miss the importance of what you're communicating to us because of it's a dense subject.
Yeah, well, there's a lot of biochemistry involved, and I don't want people to focus so much on the biochemistry. I just want them to see the magnitude of the biochemistry, not the details of the biochemistry. So anyway, as you said, we're going to do this in two parts because it's a vast amount of information, and we'll try to get the first part done in less than an hour. But there's a little bit about my background, which people can look at that later. I'm not going to go over all of that. So last time we talked about the nervous system, and this is a single neuron in the top left corner there with an axon that's myelinated. That's those little yellow, sausage-like things that go down over the nerve till the nerve gets really close to the muscle. And then there, the axon branches into several branches that innervate different muscle fibers. So that's just a little bit about the microanatomy of the nervous system. And this is a little bit more detail. When we talk about amyotrophic lateral sclerosis, which I've been focusing on for the last 4 years.
Or ALS, right? ALS.
ALS, yeah. ALS is also called Lou Gehrig's disease, and it's an upper motor neuron and a lower motor neuron disease. So it affects both the upper motor neurons in the brain as well as the lower motor neurons in the spinal cord and out into the muscles. So I've identified thus far about 44 causes of ALS, and mitochondrial dysfunction is one of those causes. Here's the list.
44 contributors to ALS.
Yeah, so that I've identified so far. There's probably others, but those are ones that jump out at us. And you see mitochondrial dysfunction is on the far right column near the top. So it's only one of 44, but it's probably one of the most important of the 44. and that's why we're
Mhm.
talking about it today. If you have, if you use ALS as your benchmark, your chronic neurodegenerative disease example, it's the most challenging to try to reverse, and that's why I've been working on that for the last 4 years. Is because I do believe that once we get ALS reversed in a large percentage of patients, that we'll be able to reverse easily Alzheimer's, dementia, and Parkinson's disease, and multiple sclerosis, and autism, and a lot of other chronic diseases.
Why?
So that's why I'm working on ALS.
How does it mitigate all those other diseases by solving ALS? Can you just briefly explain?
Well, yeah. So every one of those neurodegenerative diseases has mitochondrial dysfunction to varying degrees. Usually not as severe as ALS, but they all have mitochondrial dysfunction, and most of them have a contribution from mold or fungus. Most of them have a contribution from electro-pollution. Most of them have a contribution from geopathic. Several of the other things that are listed on this slide. But what I found with ALS and what makes it so challenging to reverse is because the average ALS patient has about 10 or 12 of these causes simultaneously. But it's a different 12 in each patient. Okay. So what I found is you have to identify all the causes in any one patient and reverse each of those causes individually. And then once you get all those causes in that patient reversed, then the patient's condition reverses, but usually not until.
Okay, thank you.
Yeah. So now we're going to go to the microanatomy of the nervous system or of the human body. So this is, in this graphic on the top of the slide, a cell membrane. That's what surrounds each and every one of our cells in the body. And it's a lipid bilayer. That means there's, lipids with fat-soluble tails hanging down from the top, and there's lipids with fat-soluble tails going up from the bottom that touch each other in the middle. And so that lipid bilayer helps us to maintain, minerals inside the cell, like potassium, and keep other minerals outside the cell, like sodium. And then I'll show you in a subsequent slide, a variety of proteins and other things impregnated into this cell membrane. But through the cell membrane, glucose, sugar, basically, can pass through a pump in the cell membrane to get into the interior of the cell. And inside the cell, it starts producing different types of chemicals that finally result in the production of adenosine triphosphate. That's the energy molecule for our cells. So you see there in the first step after the cell membrane, you have a glycolysis or glycolytic pathway, and that forms 2 molecules of ATP for every molecule of glucose that's metabolized. So that's not enough to keep the body functioning. You have to have a whole lot more than that for every glucose molecule that you oxidize. But the glucose is eventually, hopefully, converted into pyruvate through multiple chemical steps. And then the pyruvate goes inside the mitochondria. And inside the mitochondria, it enters another series of enzyme steps, which we call the tricarboxylic acid cycle, or TCA short. TCA. And so inside the TCA, we have NADH being produced and some ATP. So the NADH that's produced inside of our TCA cycle inside the mitochondria, those NADH molecules go over there to the electron transport chain. That's where you see those 3 E minuses. So the electrons from the NADH are shuttled along through those different enzyme complexes in the electron transport chain. And the final complex in that electron transport chain is the ATP synthase. It's the one that makes the ATP from ADP and inorganic phosphorus. Okay. And that electron transport chain plus the glycolytic plus the tricarboxylic acid cycle, the TCA cycle, generates 32 molecules of ATP for every molecule of glucose that's metabolized. So most of the ATP that's produced in our cells is produced via the TCA and electron transport chain. Okay. Glucose goes through the cell membrane through a special pathway and gets into the cell and produces a variety of chemicals between glucose and pyruvate that result in two ATPs being formed. That's the glycolytic pathway. And then the pyruvate that comes out the bottom of that glycolytic pathway goes into the mitochondria. The mitochondria then puts that pyruvate through the TCA, the tricarboxylic acid cycle, and it produces some NADH. The NADH goes up here into the electron transport chain and gets shuttled along with the electrons, and the NADH gets shuttled along. And the final step is the ATP synthase, which is converting ADP, adenosine diphosphate, into adenosine triphosphate with the addition of an inorganic phosphorus. That results in 32 ATPs being produced from that molecule of glucose that we started out with on the top left. Okay, so most of the ATP energy that's produced in the cell, as you see, is produced inside the mitochondria.
Right.
In the TCA and the electron transport chain. So I showed you on the top left of the previous slide the what we call the lipid bilayer membrane. Lipid bilayer, you can see in greater detail here. You see the little red circles. That's the hydrophilic heads. That means they like water. And then the tails that come down from those red circles are bound to those red circles are lipids, and they don't like water. So they might basically direct themselves toward the interior of the membrane. And the same thing happens on the other side of the membrane. The red hydrophilic heads having lipophilic tails that go up and interact with the other tails on the other side. You see in this membrane, though, in addition to what you saw on the previous slide, a variety of different types of proteins. Some of them go all the way through the cell membrane, like that integral protein, globular protein in the center. Some will go only partway through. But notice this one on the far left. This is actually a place where proteins can go through that channel, but it looks very similar actually to what's called a voltage-gated calcium.
Is it this right here?
Yeah, this what I just showed right there.
Oh, okay, there, got it, right here. Yeah.
Yeah, so that is very similar to a voltage-gated calcium channel. Now, that's really, really, really important because this little green thing that you see coming out the top of it is like an antenna, and it picks up the ambient electromagnetic signals from the environment and stimulates that voltage-gated calcium channel to open up and allow calcium to flood into the cell. When that happens, then the calcium inside the cell causes massive free radical reaction damage inside the cell. Okay? And so that's why the exposure to electro-pollution is so critical, because every time you get exposed to some electro-pollution, you're flooding your cells with calcium and causing free radical damage inside the cells from peroxynitride and from superoxide and other free radicals. The mitochondrial membranes are similar to this cell membrane that I've shown you here, and there's pretty good evidence that the mitochondrial membranes also have voltage-gated calcium channels and also little antenna on the surface. So they're being affected by the electro-pollution as well.
So really the electro-pollution is basically very dangerous for us.
Very dangerous. Just because you can't see it or taste it or touch it doesn't mean it's not dangerous.
Most of us are feeling it before, obviously, we can even understand what's happening to us.
Well, a lot of people have brain fog, and they say, I don't know why my head's so foggy today. Well, it's because if you got a meter out and measure the amount of electropollution they're getting exposed to, it'd be off the scale.
Okay.
And they're getting free radical damage inside their brain cells as they speak.
Oh.
Okay. Now, but the cell membranes and the mitochondrial membranes are both made up primarily of fats and phospholipids, and those help to maintain the electrical charge across the cell membrane. When the electrical charge difference across the cell membrane is lost, then that cell dies. Okay, so when calcium floods into the cell, that's reducing the electrical charge across the cell membrane. So then your cells are moving more toward death because of the flooding of calcium into the cell, because of the opening up of the voltage-gated calcium channels from electro-pollution.
Wow.
Okay, so these are some very interesting facts about...
Practically speaking, I know you've discussed this in the, I think, during the previous discussion we had. But practically speaking, these microwaves that we carry on us 24/7, many of us put these insults in our ears 24/7 while we work, while we push cards. It's really destroying.
Yeah, just remember that the microwave energy coming out of your cell phone is the same frequency as the microwave energy in your microwave oven that you use to cook foods. So if you want to cook your brain, put your cell phone up to your ear. Okay. Now, what I have here is a safe sleeve. A safe sleeve is a way to reduce somewhat the electro-pollution that you're getting exposed to. The best solution for using a cell phone is to put it on airplane mode, except when you're going to use it, and when you're going to use it, put it on speakerphone mode and put it out just beyond your reach and shout at it. Okay. The further the cell phone is from you, the less damage it does to your body and to your brain. Okay. Now let me go to the next slide. Now, some facts about mitochondria. Okay, these little organelles I showed you on the slide before last are found in every cell, and there's hundreds of them in every cell, except red blood cells don't have any. Okay, so red blood cells depend on the glycolytic pathway to produce the ATP energy that they use to survive. But anyway, the mitochondria produce about 90% of the ATP energy required for us to function. ATP is required for nerve conduction, muscle contractions, building cells, producing proteins. Almost every function inside the body requires ATP energy for it to function. Most patients with ALS have mitochondrial dysfunction, either genetic or envirotoxic or both. All of our, and like I said, ALS is just an example of the most severe neurodegenerative disease, like Alzheimer's, dementia, and Parkinson's, and multiple sclerosis, and autism, and so on. So just remember that we're talking about all those neurodegenerative diseases, even though I'm focusing on ALS here. All of our mitochondria come from the egg of the mother, none from dad, none from the sperm.
Wow,
Okay, so,
I never heard.
So if mom has genetically defective mitochondria, then you're going to have genetically defective mitochondria, no matter how good your dad's mitochondria were. There are about 500 to 1,000 mitochondria per skeletal muscle cell in young people, and about 5,000 to 8,000 mitochondria in each heart cell, because it's so much more metabolically active and requires so much more energy to contract continuously 24 hours a day, 365 days a year. There's about 5 single-stranded circular DNA in every mitochondria, an average of 5, but sometimes as little as 1 mitochondria, and sometimes as many as 15 mitochondria. But the mitochondria produce or cause the production of many of the proteins that are involved in those metabolic pathways inside the mitochondria where your ATP energy is produced. Okay, if you have enough mitochondrial DNA damage in the human egg conception, then that person is going to have likely a lifelong health challenge. Sometimes correctable, sometimes not. After 18 years of age, you lose about 1% of your mitochondrial function each year of life. So by the time you get 68, you expect to have only half of the number of mitochondria that you should have.
Well, that explains what's happened to me. I keep saying something's really off.
Yeah, but the good news is that you can actually do things to regenerate mitochondria and have more than what you expect for your age.
Okay.
Yeah.
I need to get on that right away. Seriously.
Yes. Yeah. The health of the mitochondria is highly dependent on what kind of fats you eat. If you eat the standard American degenerative diet, the SAD diet, or eating a lot of fast foods, which speeds you to your grave, then you're going to have diseased membranes in your mitochondria and inability to produce ATP energy inside those mitochondria. Okay,
Wow.
A little bit about mercury and mitochondria. There was a PhD researcher who got 2 drops of methylmercury on her gloved finger in 1997 and developed neurodegeneration, and 9 months later died from it. Okay, so 2 drops. Mercury is the most toxic substance on the planet after radioactive elements. Okay, dimethylmercury is much more toxic than metallic mercury, which is found in the amalgams in your teeth. But dentists are still putting mercury amalgams in the mouths of people all across the United States every day of the year. And in my opinion, that needs to be legally banned. It should not be used any further. There's other better ways to fill a cavity in your tooth. Dr. Boyd Haley described how mercury kills mitochondria neurons. The mercury is not a redox metal that would cause damage directly, but it displaces the iron from the sulfur binding sites inside your mitochondria, and then the free iron kills the mitochondria, and when enough of the mitochondria die, then your cell dies. So mercury causes death, basically. NBMI, which Dr. Haley created back about 20 years ago, irreversibly binds all forms of mercury, the methyl mercury that the woman died from, as well as metallic mercury, as well as many other salts of mercury. And it is sold on a www.purifywaterllc.com in 10-gram jars. It's sold as a water purifier because if they try to sell it for a nutraceutical or a pharmaceutical, it would be jerked off the shelves immediately. But you can use it to purify your water. I take some NBMI most days of the week, and I take about 100 milligrams, but you can muscle test to find out if you need more than that. And it's not cheap. It's about $8 a day to do that, but it's the very best thing to get mercury out of your body. I had 13 mercury fillings in my teeth until I was 42 years old, and then I developed prostate cancer, colon cancer, and unstable angina pectoris, and was at risk for dying from a heart attack or 2 cancers. So I figured out that mercury was a primary cause. So I got all my mercury amalgams out that year and started taking things to get mercury out, microscopic mercury out of my body. Dr. David Kennedy.
With let me have the material right here. The energy testing, muscle testing. You can determine, you can assess.
Yeah. So if you take 100 milligram dose, which is 1/32 of a teaspoon, and you muscle test the next day, do I need the same dose or a higher dose? And your muscle testing says that you need a higher dose, then you do 200 milligrams that day. Then the next day you test again and say, do I need the same dose as yesterday or a higher dose? And then if it tests for 300, you go to 300. Very rarely do you need to go above 300.
Perfect. Okay.
Mercury is released from amalgams every time you chew or swallow. One of my friends took a mercury vapor analyzer to Washington, D.C., and went up to representatives from the House and senators and asked them to open their mouth. And so she stuck a straw in the mouth and measured the mercury vapor that was coming from their mouth. And then she had them chew a piece of gum, and then she took the measurement again. After chewing gum, anybody that had one mercury filling in their mouth exceeded the mercury levels for safe air inside their mouth, according to the U.S. government.
Wow.
So chewing gum or food or drinking hot fluids is going to release mercury from your amalgams. Okay, dietary effects on mitochondria. These are very important. If you have pesticides or heavy metals or certain other toxins in the food, that's going to disrupt your enzymes inside your mitochondria and also mess up your mitochondrial membrane, your cell membranes. If you eat oxidized fats or trans fats would be like margarine or partially hydrogenated vegetable oils that you find on the label on lots of different products that you find in the center of the store. Those partially hydrogenated vegetable oils, when those fats from those get incorporated into the cell membrane, it causes a defect in the cell membrane or the mitochondrial membrane. Now, there's also oftentimes deficiency of certain phosphatidyl groups in our diets. That's phosphatidylcholine, ethanolamine, serine, and inositol. But if you don't have enough of those phosphatidyl groups in your cell membrane, then you're going to develop a disease process, a dysfunction of your mitochondria and so on. Now, dietary fructose is rapidly phosphorylated, a phosphate's added on to using the ATP, and that uses up your ATP reserves. And so, as a result, fructose is harmful because you're using up ATP that's really important to be used for other purposes. Fructose increases the uric acid production in your liver, which causes mitochondrial oxidative damage. That causes inhibition of one of the mitochondrial enzymes there, aconitase, and also accumulation of citrate inside the mitochondria, which stimulates triglyceride synthesis. When you produce a lot of triglycerides and you don't produce a comparable amount of HDL cholesterol. That results in metabolic syndrome, syndrome X, where you have unresponsive insulin receptors on your cells. The metabolic syndrome is responsible for obesity, strokes, heart attacks, arthritis, cancer, and a lot of other chronic diseases, hypertension, diabetes. So you don't want to get syndrome X, you don't want to get metabolic syndrome, so you need to avoid fructose. If you read labels, a lot of the products say high fructose corn syrup. Now, most sodas that are produced in the United States are made with high fructose corn syrup. So don't do sodas at all. That would be a really bad idea. Fruit juices have quite a bit of fructose, and table sugar is about half fructose and half glucose, so table sugar is not much better. So if you want to sweeten something, you ought to use monk fruit from Now Company or stevia liquid from Nutrimetics Company, because both of those will sweeten your thing that you want to sweeten without putting fructose or sucrose or glucose into your body. Now, beta-hydroxybutyrate is a keto acid that's produced when you're on a ketogenic diet. But anyway, the ketogenic diet and the beta-hydroxybutyrate reduces the reactive oxygen species that are damaging the mitochondria. And so that, as a result of doing that, that improves the mitochondrial respiration, the ability of the mitochondria to metabolize sugar into substances that result in production of ATP. So the best diet for most patients with ALS or any other chronic neurodegenerative disease is a ketogenic-like diet with only healthy fats. The best fats to consume are squid, octopus, scallops, shrimp, and krill, because they are high in the DHA plasmalogens that are necessary for a healthy cell membrane and healthy membranes of your mitochondria. Okay, so this is a lab report from the Genova Diagnostics Lab. First here was the mitochondrial dysfunction at a 9 out of 10 level.
Okay.
Okay.
Yeah.
And then the others are not so good. 7s are pretty bad. You really want to be 3 or 4 or less. Okay, and so this patient had major trouble. At the bottom of the graphic, you can see the antioxidants and the things that are associated with oxidative damage. When you have a lot of free radicals forming inside your cells, inside your mitochondria, because you don't have enough antioxidants, then that causes lipid peroxides to be formed. And some of those come out in the urine. It can be tested on the Genova Diagnostics test, and then you know that you have trouble. You see the lipid peroxides down there are at 7.1, which is right at the zone between A and problematic.
Yeah.
And then right below that is the 8-hydroxy dioxyguanosine, which is a measure of the oxidative damage to your genetic material inside your cells, your DNA and your RNA. Okay, and that's also in that borderline between okay and danger zone.
Wow.
Okay, so this person's got some trouble. You see, their glutathione is right between okay and danger zone. The glutathione is the most important antioxidant that cell produces besides melatonin. I'll get to that in a few minutes. Okay, now, this Genova Diagnostics test also evaluates your lipids to find out which lipids are high, which lipids are low, which lipids are just right. If they're green, if your measurement is in the green zone, you're right where you want to be. But you see several of these are in the red zone, outside the range. Stearic acid, oleic acid, I don't know, there's several of them that are outside the ideal zone.
To get practical about this, can I ask you? Because I'm sure everyone's asking this question that's listening.
Yeah. So let's say that you find that you're really high in oleic acid, then that may mean that you're eating way too much olive oil, because olive oil has high oleic acid content. And let's say that you see down at the bottom, on the bottom right.
Yep, I see.
Let's see. Wait, is that where it is? No. I'm sorry. It's the top left. Top left, you see eicosapentaenoic acid, EPA, is at 4.4. That's right in the middle of the green zone. That's good. But the docosahexaenoic acid is DHA, and DPA are both low. They're in the yellow zone. Now, the most important fat for the brain is DHA, docosahexaenoic acid. It's the most prevalent free fatty acid in the brain, and it should be attached to a lot of the phospholipids that are in your cell membranes. But if it's not, then you can't produce antioxidants very well. You can't neutralize the free radicals that are being formed inside your mitochondria very well.
Wow. And this test is accessible to anybody that goes to the website?
Yeah. So I think that Genova Diagnostics may require a physician prescription or physician recommendation,
Okay.
but it's an easy enough test to order and run. And probably a lot of people would benefit from knowing the answer that they would get from running that test. Now, there's a couple of articles there on the top bullet which show that the mitochondria are related to neurodegeneration. Okay, so if your mitochondria are defective, then you're likely going to have neurodegeneration. Mold mycotoxins poison the mitochondria. I have a lot on that on a subsequent slide. And then the electro-pollution, which we talked about, opens up the voltage-gated calcium channels and floods calcium into the cell, which causes free radical damage inside the cell. The most important substance to prevent that, other than avoiding the electro-pollution, is magnesium. Magnesium reduces the amount of calcium flooding into the cell. The U.S. government has told us that 57% of the American public are deficient in magnesium. If they say it's 57%, I know it's probably at least 87% because they always underestimate nutritional deficiencies by at least that amount at the federal government level. So you want to be taking magnesium 4 times a day after
meal. What kind?
Yeah, I'm going to say it.
Okay.
The most effective magnesium for most people is magnesium malate. Also, other effective forms are magnesium taurate, magnesium threonate, magnesium glycinate, magnesium 2-AEP. So what I usually do is rotate 2 or 3 different ones. So if you're taking it 4 times a day, take a different one each time of the day. So you got 4 different products, 4 different doses.
Good idea.
And you don't develop an allergy reaction to the magnesium that way as easily. Okay, most people that are chronically ill have leaky gut and form allergies easily to something that you're taking 4 times a day. Okay, the other thing that happens when you flood calcium into the cell through the voltage-gated calcium channels is you get a stimulation of the N-methyl D-aspartate receptors. Those are the ones that bind glutamate. Glutamate causes neuronal death. Okay, so if the NMDA receptors on the mitochondria mediated neural injury, you can see that on that reference there. Okay, excess calcium is in the cells gets sequestered by the mitochondria, which then causes the mitochondria dysfunction and eventually die. So because you allowed your body to get exposed to the electro-pollution in the first place, then you're killing off your mitochondria faster than they should be killed off. What a deal. Now,
out of everything you're saying, that's so important. It's something so simple and straightforward people can do today.
Yeah. Well, the most effective shielding most effective device I've found to help reduce the harmful effects on our body from electro-pollution is the Blue Shield products. That's BLUSHIELD, not BLUESHIELD. And the one that works for most houses is called the PHI-2, PHI-2, and that's $350. But it's a plug and leave. Plug it into an electric socket somewhere near the center of your house, and then you ignore it after that. And it reduces the harmful effect on the body from both transverse waves as well as scalar waves from the electro-pollution that you're getting exposed to. In addition to that, you'd always want to try to turn off the breakers that go to your bedroom at night. You want to turn off the Wi-Fi in your home every night. Try to reduce the EMF as much as you can, and don't rely exclusively on the Blue Shield because it only reduces the harmful effect on the human body by 80 to 85%. But if you have massive amounts of electro-pollution in your house that you're not doing anything about, then 80 to 85% of that is not enough.
Yeah.
Okay, so again, the high-frequency electro-pollution is about 1/6 of the harmful effect on the body. from transverse waves, which is shielded by the bed canopy, but 5/6 is not shielded by the bed canopy, but is shielded by the blue shield. Okay, so that's why you want to have a blue shield in addition to a canopy if you have a canopy. Okay, reducing the electro-pollution decreases the calcium flooding into the cells, the free radical damage inside the cells and inside the mitochondria, the rate of growth of the mold, and the rate of production of the mold to produce mycotoxins. So that's really important to get rid of as much of the MF as you can. 80% of the healing should occur while we're asleep if we're in the parasympathetic mode. But if we're being exposed to electropollution, we're not going to be in the parasympathetic mode and we can't heal our body while we sleep. Now, also, electropollution trains our brains into a higher frequency, somewhere above 50 hertz. The wall circuit is 60 hertz in the United States, and the Wi-Fi is a lot higher than that in frequency. But if you don't shield yourself from the electropollution in some way, then you're going to not be able to have delta waves, and you have to have delta waves in order to have REM sleep, rapid eye movement dream sleep, to heal your psyche. And that's why I think there's so many crazy people living in the cities. They're not ever having REM sleep and healing their psyche while they sleep. Also, if you have high MF, the gut flora.
We are seeing this in mass scale.
Yep,
we are absolutely all witnessing the effect of this.
Yep. But anyway, that 5-2 device from Blue Shield reduces the harmful effect on the human body for about 45 meters, which is about 130 feet in every direction. Okay, so it's usually one device is enough for most houses. You'd have to have a mansion in order for it to not cover the whole house. If you plug it in the center of the house.
How much did you say it was?
$350.
Wow.
But how much money are you going to spend on your health trying to fix all the problems that are created by the electropollution if you don't shield it? Think about that. Okay. If you're exposed to electropollution, your gut flora cannot make as much melatonin. A lot of people think that all the melatonin in their body is produced in the pineal gland, but actually the gut flora produces 100 to 1,000 times more melatonin than the pineal gland. And melatonin is a strong antioxidant. So if you're not producing melatonin, you're losing a lot of the antioxidant protection that you need. You need to unplug the Wi-Fi at night, turn off the electric breakers that go to your bedroom, put your cell phones in airplane mode, and make sure that the Wi-Fi and Bluetooth are turned off on your cell phone before you get into bed. And then get rid of the cordless phones in your home. It'd be better to never use those. Unplug them and put them in the closet, or give them to your worst enemy. But don't keep them utilized in your home. And switch your radio frequency burglar alarm systems to wired, because it's zapping you all night long. Also better to remove the smart meters from your home if you can. Okay, now we've got a little bit of information about the biochemistry here. At the top of this graphic is the different macronutrients that we eat in our diet, the fats, the carbohydrates, and the proteins, coming into the cell to be metabolized. Okay, so you see that all of those eventually end up in acetyl-CoA. Acetyl-CoA is made from vitamin B5 and an acetyl group, which is gotten from these fatty acids or carbohydrates or proteins. The acetyl-CoA is supposed to go into the interior of your mitochondria, into the citric acid cycle. It's also called TCA cycle, we talked about earlier, tricarboxylic acid cycle. And inside that cycle, it's supposed to produce a lot of NADH and a lot of FADH, which is down at the bottom. You see the little arrows coming out of that circle that go to complex 1 and complex 2. Those are produced by the TCA and are necessary for the electron transport chain, which is that bottom row. The electron transport chain causes the different molecules that are given to it to shuttle along through it and releasing hydrogen into the membrane space. And then at the end, I'll show you on a subsequent slide what the hydrogen does to make ATP. Okay, hydrogen and phosphate and magnesium. You see down there coenzyme Q10. Dr. Folkers at the University of Texas, Austin, back in the 60s, figured out that if you're 50 years old in the United States, you have a 50% chance of being deficient in coenzyme Q10 production in your body and should take it as a supplement. If you're 70 years old, you have a 70% chance. If you're 90 years old, a 90% chance. If you make it to 100, you're deficient. And so people listening here that are over 50 probably should be taking coenzyme Q10 in an oil gel cap to be able to get enough into their electron transport chain to make ATP energy in their body.
What's the best company to buy this from?
Well, I use Bessie Best 800 milligrams per capsule oil gel cap because it's the most cost efficient. I take one of those every other day. So 4 per week is pretty inexpensive, or 3 or 4 per week. Okay, you also see down there on the far right side, glutathione. Glutathione is a very important antioxidant. Melatonin, as I said, is another very important antioxidant for the mitochondria. And by the way, all mitochondria produce melatonin also. So it's not just the bacteria in our guts, but it's also the mitochondria inside our cells producing melatonin to act as a free radical scavenger, antioxidant. Now, you'll see over there on the left what influences how ATP energy is made from carbohydrates, fats, and proteins. The nutrient imbalances, if you're deficient in magnesium, vitamin B5, vitamin B3. Vitamin B3 is the building block for NAD that's down there on the bottom left. Vitamin B2 is the building block for FADH. So if you're deficient in those nutrients, your cycle's not going to work. You're not going to produce ATP energy. Low tissue oxygen. Oxygen is the final electron acceptor. I'll show that better in a subsequent slide. And then if you have excessive tissue acidity, then that causes all these enzymes to crawl to a slow pace or even come to a screeching halt because they can't function in excessive acidity. The enzymes can become toxic from pesticides, herbicides, heavy metals, mycotoxins, and all kinds of other things. Electro-pollution causes the calcium flooding into the cell and free radical damage, so then the electron transport chain especially doesn't work very well. Then excess free radicals from other sources. There's all kinds of free radicals in food, water, and air that we get exposed to. Anyway, this graphic is also from Genova Diagnostic.
Yeah, I don't know why I'm asking this real quick around that particular slide, but if somebody is having any form of eczema, skin condition, skin disease, and I'm finding a lot of people are having those, and the emotional constitution of that, I think we're clear on. But do you have anything to say about this particular graph in mitochondrial dysfunction? In the context of, for example, something as simple and basic as eczema?
Well, the largest detox organ in the body is the skin. And so if your skin gets exposed to toxins, it's going to take up toxins. If you go in infrared sauna, the toxins are going to come out through the skin. So the skin oftentimes houses a lot of toxins and creates an environment that makes it easy for skin conditions to occur, whether it's eczema or psoriasis or acne or any number of other things. But the emotional conflict is usually separation. And so we load up our skin with toxins, and then we get the emotional conflict, and presto bingo, we have the eczema. Okay, so now this is a kind of a blow-up of what was on the bottom row on that other graphic. Only a couple of points to be made on this that you see on the far right there. ADP, adenosine diphosphate, is converted to adenosine triphosphate in the presence of magnesium and inorganic phosphorus. You have to have inorganic phosphorus to make the ATP. You have to have an additional phosphate. Now, what a lot of people miss and don't understand is this part. The mitochondria produce cellular water. So if your mitochondria are dysfunctioning, then you're not producing enough water inside your cells to keep your cells healthy, and the cells become dehydrated and eventually die because of dehydration. Okay, so the water, a lot of people think, well, I just got to drink more water. Well, you got to get it into the cell first. And so if the water is being made in your mitochondria and then coming out into the cytoplasm, then it keeps your cells hydrated from the inside out. If you drink water, the water's got to get into your cells somehow before it can do the job. Okay, this is a blow up of the tricarboxylic acid cycle. The main thing I want to show you on this is the red on the right, the red. You see the NAD is converted to NADH multiple times there. And the NAD should be 700 times greater than the NADH concentration if you want to be able to have this complex of enzymes work. If the NAD is not 700 times greater than the NADH, then this all comes to a screeching halt. And it's the NADH that's used in that cycle on the previous page. You see down there at the bottom left, NADH goes into the electron transport chain and gets the electrons in it, gets shuttled along, and the electrons finally are used to make water with a final electron acceptor, which is oxygen. It says 1/2 O2, so it's 1/2 a molecule of oxygen plus 2 molecules of hydrogen produces one molecule of water. Okay, now there's a bypass nutritional product that's available. I'll talk about a little bit more in a subsequent slide. So look at the on the right side of the circle, the alpha-ketoglutarate that's underlined in red. If you give a patient alpha-ketoglutarate and enough vitamin B3 to make NAD and enough vitamin B2 to make FAD, then you can actually make a lot of ATP in your cells, even if you have a major obstacle up there at the top in conversion of pyruvate into acetyl-CoA. Okay?
Got it.
Yeah. So that's the bypass, metabolic bypass, which I'll talk about in a subsequent slide. But that's what that bottom bullet is saying. Alpha-ketoglutarate plus the vitamin B2 to make FAD, the vitamin B3 to make NAD can make more ATP. And that would work in whether it's ALS or Parkinson's or autism or Alzheimer's dementia. All of those conditions have a defective ATP production.
Got it.
Okay. Now, mold produce mycotoxins. Mycotoxins produce enzymes. You don't have to remember which enzymes that produces. That's that first 4 bullets. On the Genova diagnostics, which I'll show you in the next slide, you can actually figure out which enzymes have been messed up because those are measured on the Nutri-Eval. The Deanna protocol is what we use to get the alpha-ketoglutarate into the body along with arginine. Arginine is a very alkaline amino acid, and alpha-ketoglutarate is a very acidic metabolic product that goes into the TCA. And if you put those two together, then you get a fairly balanced pH, and then everything works. You have to have sometimes liposomal NAD plus, or if you don't want to take liposomal NAD plus, you probably need to do an ozone therapy once a day to bring your NAD plus levels back up so you have enough to make some ATP energy. But with that bypass pathway, you can produce 32 molecules of ATP energy instead of just 4. 4 is only 12% of what you need, and your cells cannot survive on 4% of the ATP.
Okay.
Yep. There are some references for how the mycotoxins adversely affect the mitochondria and the ATP production and the health of the cells.
I really appreciate that list. Can we go to the previous slide for a minute? Really appreciate that because people can take their time to really dig deep into the density of this conversation, and the implications is significant. So this is something we can all become students of right here. References for previous slides, so you get full context here for the things that you touched on.
Yeah, a lot of people don't realize that half of all the homes and half of all the businesses in the United States are mold infected and infested. And that means that half of all the homes and office buildings are loaded with mycotoxins in the air that you're breathing. And so you're poisoning your mitochondria continually by breathing mycotoxin and mold-contaminated air. Okay?
So
So
for a person who's listening that has no idea what you're talking about, and you're in a home, for example, that we know is mold infected, if somebody was having a brief conversation, what would you say?
Yeah. So what people want to do to find out whether they are part of the problem, where their home or their office space is part of the problem for their low mitochondrial function, low ATP production, is they would go to my personal website, drleecowden.com, and there's 3 or 4 articles there that talk about mold. And one of them tells you how to test your house for mold for $30. Another one tells you how to, if you find that there's a problem in one of those rooms with the Sabro culture plates, then how to find the water leak in that room so that you can get that stopped and get the building materials remediated if necessary. And then how you get the mold and fungus out of your body and how to get the mycotoxins out of your body. All that's on some articles on my personal website, drleecowden.com.
Thank you.
So it's really important to understand that a lot of the things we talked about on those previous slides will cause increased glutamate production by the cell, increased glutamate release from the cell into the surroundings around the cell. When glutamate builds up around the cells, it causes neuronal death. It causes death of the brain cells and the spinal cord cells and so on. Now, because glutamate is such a problem, or can be such a problem, it's important to know how you can reduce the glutamate in your body. And so this is a list that I got off the internet. There's a reference for it there at the top. And so you can learn how to reduce glutamate in your own health. But glutamate is the most common neurotransmitter in the brain, and it's an important one because it causes neuroexcitability. But if you have too much of it, it causes neuronal death. So you want to, it's like baby bear's porridge. You don't want to have too much, too little, too hot, too cold. You want to have just right amount and just right temperature. Okay. So
for those listening that can't watch, can you go back a little to that last slide, Dr. Cowden, if you don't mind?
Yeah.
And ways to reduce, can you just read those?
Yeah, so the ways to reduce brain glutamate, reduce stressors of all types. A lot of people hear the word stress and they think about emotional stress, but in many cases, that's not the most significant stressor. The other stressors include electromagnetic pollution, geopathic stress, chemical stress from pollutants in the environment, or the foods or the water, microbiological stress, structural stress from your joints being out of alignment, and then mental emotional stress also in that list. You want to avoid loud noises. Loud noises, especially during the night when you're trying to sleep, are going to cause the glutamate to go up, and that's not a good thing while you're sleeping. You don't want to be excited while you're sleeping. You want to be relaxed and subdued while you're sleeping. A variety of toxins will cause the glutamate to go up. You want to detoxify often, usually with an infrared sauna, do exercise or yoga, meditation or prayer, neurofeedback, get deep sleep, stay hydrated, get some acupuncture or electroacupressure. You can buy a AccuDoctor for $65 on Amazon and treat your own acupuncture points and get your glutamate to come down as a result of that. Exposure to cold. Get into the shower, put the shower on very warm, and then at some point during the shower, turn all the hot water off and stand there in the shower with just cold water. And that actually reduces glutamate. Avoid monosodium glutamate. Monosodium glutamate is found in a lot of Oriental foods and also Mexican food, and oftentimes you'll feel an abnormal flush of your skin after you've consumed something with MSG in it. But monosodium glutamate, in my opinion, should be avoided completely by everybody. Aspartame, NutraSweet, is an artificial sweetener that raises glutamate. Drinking alcohol, consuming excessive amounts of caffeine will raise your glutamate. To lower your glutamate, you want to take gamma-aminobutyric acid, GABA, G-A-B-A. You can take zinc, magnesium, omega-3 fats, vitamin C, vitamin E, vitamin B6, theanine, taurine, curcumin, resveratrol, and N-acetylcysteine. All of those, and in that website at the top has has at least 29 references that you can look up. I think it's more than that, considerably more than that, but lots of references that you can look up about each one of these.
I think it's optimal living dynamics or something like that, but it's at the top of that slide.
Yeah. Okay, so when we get together again, we're going to talk about some more things on the mitochondria. So we got a good start today. You got I think an overview of how important the mitochondria are and why it's so important to do things that will protect your mitochondria, that will help your mitochondria to regenerate. We'll talk a little bit more about mitochondrial regeneration in the next part 2 coming up.
Thank you so much, Dr. Cowden. It's going to take me a month to digest this, but thank you. It was a feast. Thank you, and thank you.
You're welcome.
We'll look forward to part 2.
We hope listening to this episode has brought you closer to experiencing the freedom of wholeness and healing. If you have questions or comments about today's episode, or for updates about R.E.S.T, please visit our Instagram or Facebook at The Place of R.E.S.T. If you would like more information about Virginia, or to support and join the cause of R.E.S.T, please go to theplaceofrest.com/donate or call 949-289-5935. Thank you for listening to R.E.S.T with Virginia Dixon. We'll see you next week.